We will proceed to the problem number 5 and projection of prisms and cones. This is the problem on cone. The problem goes like this. A cone of 50 millimeter base diameter and 60 millimeter axis length rests on HP on one of its generators. Draw the projections when the axis is inclined to VP at 30 degrees. Look at the data, how simple it is. It says cone of 50 mm diameter, axis height is 60 millimeter. It is lying on HP on one of its generators. Very important, lying on one of its generators. Draw the projections when the axis is inclined to VP at 30 degrees. He has not told you when the plan of the axis inclined to VP, top view inclined to VP, appears, all such words are not there. When the axis inclined to VP at 30 degrees, we have to find the beta angle now. We have to find the beta angle in the last step. The answer goes like this. We have here a cone. I have a cone here. Initially, you draw the cone in this manner. Draw the top view, front of the cone. The very first step, make the cone lie on the generator. In this manner. In the top view, what will happen? The circular base, it appears like an ellipse, and that is an apex point in the top view. Since the base is nearer than the apex, the base is fully seen, the ellipse is fully seen. The second step, make it inclined to VP at a beta angle, because here what will happen in the top view, the axis, apparent axis. Originally we have a true length of the axis. The moment it lies on the generator, the axis length becomes apparent. So that is inclined here, find the beta angle. But the problem wording clearly says the axis inclined to VP, find the beta angle. Now if we incline like this, in the front view, the base ellipse is fully seen. If we can make it in this manner, in the front view, base ellipse is not fully seen, only outer border seen. I repeat the step. Initial figure, make the cone lie on the generator, draw the top view, front view, make it inclined beta angle, draw the top view, front view. That is the three figures or 3 steps you carry on. Initial figure, first step, and the second step. The answer goes like this for the present problem of the cone having 50 mm diameter, 60 mm is the height. 50 mm diameter and 60 millimeter is the height. Let us see here. I'll draw here the top view, front to the cone. I'll draw now top view, front to the cone. The diameter and the height is given to you. I'll just draw the top diameter, height is given to you. That's what we have. Here. Let me draw diameter 50 millimeter. Draw the top view, front to the cone, 50 mm diameter. 50 mm diameter, you draw the cone. Circle, top view. Center, we have O here. Now project and draw the front view. Draw the projectors, draw the front view. The height is given to you. It is 60 millimeter is the height. So draw here the height, long and short, long and short, long and short, long and short. And that is the base of the cone. And draw here the height. 60 mm is the height. 60 is the height. That is 60 mm is the height. O dash. We have here O1 dash. Here we have O1. The dimensions are very clearly show you the dimensions. The height is being 50 millimeter. 50. The height is being 50 millimeter. The diameter of the cone, base diameter, I can just mention here the base diameter. The base diameter is the 60 mm is the height. This is 60 mm is the height. Then diameter is 50 mm. That is diameter, which is 50. Diameter 50 mm. 60 mm is the height. So that's what the dimensions clearly given. 50 mm diameter, 60 mm the height. 60 mm height, 50 mm diameter. I draw the top view, front of the cone. I have to make the cone to lie on the generator, one of the generator, and draw the top view down. So draw generator. Let me start the procedure and divide the circle into equal number of parts. As I told you, when the base is inclined, the base will appear like an ellipse. When it is inclined, it will appear like ellipse. So divide this into equal number of parts. As I told you, lamina, circular lamina, we already discussed about here. Divide this into equal number of parts. Project them here. Let me name this as A, B, C, D, E, F, G, H. Project them. We have here A dash, B dash, C dash, D dash, E dash, F, then G, and then H. So I have projected in D and F happens to coincide. C and G happens to coincide. These are all regularly we already did in lamina. Reproduce this front view here, such that this it is lying on a generator. There is a generator AE. Like a compass cutting method, reproduce. Measure O dash E dash, mark here O dash E dash. Measure OE, mark here OE. This will be O dash here, this will be E dash here. Then take this measurement OA. From O you draw one arc, then EA, from E you cut an arc. You get the triangle, the entire triangle is drawn here. The entire triangle is reproduced here. Entire triangle being reproduced in this manner, And locate the midpoint, draw the axis please, locate the midpoint and draw the axis. So we find here the cone is lying on one of its generator. This measurement must be same. Locate all the 8 points of the base. All the 8 for the base you locate and name them properly. You have here A, B, C, D, E, F, then G, and then H. Project now. I had told you the base is nearer, the apex is away, the base is fully seen as an ellipse. The circular base will appear like ellipse. Draw projectors of all the 8 points of the base. On the circle we already divided 8 equal parts. Draw here the locus lines. Draw the locus lines in this manner. Locate the points and complete the ellipse. Locate the points, and this point will be O. You name them. You name them. We have here A, B, C, D, E, F, G, and then H. The ellipse is fully visible. Draw here the ellipse. The base ellipse is fully visible. Draw very neatly. From O, you draw the tangent to the maximum bulged ellipse. Because the cone has got infinite number of generators. We have in an axis long and short in an axis, which is actually O1. Now, I just make a small information to you at this point of time. I have seen students drawing ellipse. We have an extreme point here C, extreme point here, we have here G, let us say we have here O. Never join OC and OG, never do that. This is wrong. What you do, you should draw from O the tangential to the base ellipse. From O, you should draw tangent to base ellipse. You should draw from O, from apex O, draw tangents to base ellipse. Because we have infinite number of generators. Extreme end generator only you have to draw when you project. Now this is inclined to VP. We have to find the beta angle. I'll tell you very clearly. Draw the projection when the axis inclined at 30 degrees. find the beta angle, reproduce the figure here and get the front view. Get the front view. Let me find the beta angle. The angle is given as 30 degrees. So for true angle is 30 degrees. So I will just find out beta angle and do it. Very simple. We have been doing it since a long time. Draw here a 30 degree line. That is a 30 degree line. You measure out the true length, that is 60 mm. So mark here, this is O. Measure 60 mm true length of the axis. 60 mm true length of the axis, O2. Draw here locus line. Measure O1 apparent length, O1 apparent length, and that is the axis. That is the axis. There's an axis. You find this angle is beta angle. That is the beta angle. You extend the apparent axis, that apparent beta line, you extend backward. This ellipse you have to reproduce by drawing perpendicular to the beta line. These are all the measurements drawn perpendicular to beta line. These are all the measurements drawn per beta line. All the measurements from taken here, all the grid. I'm telling you, you should draw the grid, ellipse grid. Get the ellipse grid here, complete the ellipse drawn here. That the ellipse must be drawn here. You draw the ellipse, reproduce. Take the 8 points and draw the ellipse carefully. 8 points and draw the ellipse. From O, you draw here tangent. From O, you draw here tangent. Which indicates I reproduce the figure here, projecting at the front view now. Carefully, the entire grid, as we did lamina, the grid, you reproduce here, get the things done, and project now. So this is the beta angle, the axis is inclined to beta angle. Project and draw the front view. Since I am just proceeding on the freehand sketching, I'll project all the 8 points. I'll project all the 8 points in this manner. Then apex point here, and draw here the locus lines, all the 8 points locus lines. Get the point here. This point will be O dash. We get an axis, and you get an ellipse. You get an ellipse joining all the 8 points. Slow, carefully you join all the 8 points. You get the ellipse here. From the front view, the base is nearer, the ellipse is fully seen. The ellipse is fully seen in the front view, the base is nearer. Locate the center from here to here, from here to here, locate the center. Draw the axis. Draw the axis. From the point view, draw the tangent. Tangent to the ellipse. Tangent to ellipse, please keep in mind, tangent to ellipse, you complete them. This is how the front view is completed. Front view is completed where the base is fully seen. The base is fully seen in the front view. So the axis here, it is inclined. The plan of the axis, the top view of the axis, inclined beta angle. Top view of the axis, inclined beta angle. The total true length is given as 60 mm. I done regular procedure. I had drawn 60 mm, then locus line, then the apparent length cut, beta angle, figure tilted for beta angle, projecting it. This requires a small amount of concentration because you have to carry on with the 8-point procedure. 8-point procedure to carry on. Small amount of concentration required while you work on the ellipse construction. Finally, I could say a cone of 50 mm diameter, 60 mm in height, lying on one of its generator. I got the top view, and this axis is inclined to VP at beta angle. Reproduce the figure here, get the front view. This is the final answer. Final answer for the problem under consideration. Under consideration, this is the final answer.